All right, let's take a look at this extra review worksheet to prepare you for your quiz retake and just review some of the concepts of factoring that we've been doing over the last week. If you take a look at this page, there's 12 different problems or 12 various factoring problems that have different processes depending on what information you're given. On all of these problems, the first thing that I look for, the very first thing, is I look for the greatest common factor. If you have a greatest common factor, factor that out. Once I've done the greatest common factor, the second thing I do is I just then factor it, factor what's remaining, depending on how many terms I have and the numbers in front of the x squared. So if I take a look at the first few examples here, really the first four examples that I put on this worksheet are really the four different types of factoring that we expect you to see without the greatest common factor. But later on, the greatest common factor will come up where you have to combine greatest common factor with your factoring. So if I look at number one, what I like to do is I look at how many terms do I have? Do I have 2 terms? Do I have 3 terms? Do I have 4 terms? In the first one, I have 3 terms. Okay. So with it being 3 terms, that's where I look at my leading coefficient. Since it's just an x squared, I don't have a number in front, I don't have to multiply. So now all I'm doing is looking at factors of negative 27 that add to negative 6. So if you have to, start listing the factors. 1, 27, 3, and 9. Those are the only factors of 27. So the thing here is, since it was a negative 27, one of these factors has to be positive, one has to be negative. So I suppose you could have negative 1 and 27, 1 and negative 27, negative 3 and 9, and then 3 and negative 9. So the question is, which set adds, again, to that negative 6? Look at that last pair. 3 and negative 9 add to negative 6. So it factors to, remember the x squared makes the x and x, then we have the plus 3 minus 9. And we're done. The only thing that I always tell students that I always like you to do is check. X times x is x squared. X times negative 9 is 9x. And 3x give you your negative 6x. 3 times negative 9 is negative 27. All right, let's move along to number 2. Number 2, I'm thinking, all right, do I have a greatest common factor? 4 and 81, don't have any number in common. Here I only have 2 terms. Since I have no greatest common factor, look at these 2 values here. Perfect square, perfect square. So this is a difference of perfect squares. Remember what differences of perfect squares, you basically take the square root of each term and put them in their respective spots. So with 4x squared, we'd go 2x times 2x. With 81, we'd go 9 and 9. But since there is no middle term, like the previous one over here, we had negative 6x as a middle term. Here we don't have any, so they have to be opposites of each other so that they cancel each other out. Because if you check the middles here, 18x, negative 18x, that adds up to 0. Hence why this one works. 4x squared and then minus 81, the middles cancel out. All right, continuing on with number 3. Number 3 is a more challenging one. This is one where we do have a lead coefficient of 3. But 3 doesn't go into 17 or 10, so I can't factor out a greatest common factor. But I do it just like I do number 1, except What I'm looking for is multiples of, I take the 3 times the 10. So I'm looking at multiples of 30 that add to 17. So again, I need to list my factors. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. Now, do you always have to list all these? No. You can list them until you get the pair you're looking for. I'm looking for 2 that add up to 17. And some of you might have been able to stop right after the second one. 2 and 15. So what I do is, I rewrite this 17x as 2x plus 15x. Now, I need to carry down the other two terms, the leading term, 3x squared, and the constant term, 10. And notice now how I have 4 terms. Okay? Anytime you get it to 4 terms, you want to now factor it by our grouping method. So I take the first 2 terms, and I ask myself, what do they share? They share an x. When I pull out the x, I'm left with 3x plus 2. When I take a look at the last 2 terms, I do the same process and I ask myself, what do they have in common? And 15 and 10 share a 5, leaving me 3x plus 2. So now, if you look at it, I have x sets of 3x plus 2's, and I'm adding 5 more sets of 3x plus 2. So I have a total of x plus 5 sets of 3x plus 2's. Now, once I have my answer, again, check it. X times 3x is 3x squared. X times 2 is 2x. That's that 2x. 5 times 3 is 15x. Those add to my 17x. 5 times 2 is 10. All right, moving along to number 4. Number 4, notice how many terms you have. You have 4 terms, right? So, just like our previous one when we created 4 terms over here, right here, okay, we can go right to factoring by grouping. So I'm going to group the first 2 terms together and see what they have in common. So I can factor out an x squared. I'm left with x plus 8. Anytime that leading term has a negative, factor it out. I'm going to factor out the negative 5. I'm left with x plus 8 because I pulled out the negative. Notice how these 2 terms are the same. Factoring by grouping only works if the terms are the same inside the parentheses. So I have left here x squared minus 5 sets of x plus 8. Now this is one where it can be tricky at times. I just need to check here, x squared minus 5. 5 is not a perfect square, so I am done with my factoring. Again, we'll FOIL it out, x cubed. X squared times 8 is my 8x squared. Negative 5 times x is my negative 5x. Negative 5 times 8 is my negative 40. It is factored correctly. All right, so those are the basic 4 without any greatest common factor. So the last 8 here are going to be more mixtures of these 4 types of problems along with some greatest common factors. So I am going to speed it up just a little bit here. So, number 5, I'm looking for multiples of negative 72 that add to positive 1. So I'm looking for factors that are really close to each other. So like this 1 and 72 and 2 and 36, 3 and 24 probably aren't going to be it. You know, I can keep on going, 4 and 24, 5, 6 and 12, 7 doesn't go in there, but 8 and 9 do. Those 2 are only 1 apart from each other. So I know it's going to be x, x, 8, and 9. Now since I want a positive 1, the 9 has to be positive, the 8 has to be negative. And we got number 5 done. Number 6, 8x cubed minus 32x squared. Only 2 terms, so I'm thinking at first, difference of perfect squares. However, 8's not a perfect square, neither is 32. Here's where I finally have one where I'm looking at greatest common factor. What do they have in common? And I'm picking the greatest. They both share an 8, and they both share an x squared. So when I pull those both out of each term, I'm left with just x, and I'm left with minus 4. I know that 4 is a perfect square, but x is not a perfect square. It'd have to be x squared if I had to continue. I am done. So sometimes greatest common factor, that's all I need to do. All right, continuing on. Number 7, x squared minus 11x plus 30. So again, I'm thinking of factors of 30, so multiples of 30 that add to negative 11. So x, so I know it's not 1, 30, 2, 15, 3, 10, 5, 6. Both have to be negative, so minus 5, minus 6. They both have to be the same sign since the 30 is positive. That one works out. All right, number 8. 3x cubed plus 21x squared plus 30x. I'm asking myself here, cube, only 3 terms. I'm thinking again, greatest common factor. So I can pull out a 3 and an x. When I do, I'm left with x squared plus 7x plus 10. When I do that first step, greatest common factor, I still need to look at what I have left. Like in the previous one, I only had x minus 4. That was done. But here I have 3 terms, just like this previous one. Now I'm looking at factors or multiples of 10 that add to 7. Well, it's either 1 and 10 or 2 and 5. 2 and 5 is my only pair. So I have x plus 2, x plus 5. So that's a 2-stepper. And you'll have a few of those on your quiz where you're going to have to do multiple steps. All right, number 9. Here again, just like our previous, or not previous one of our earlier ones, I think it was number 3. Here I have a 4x squared, doesn't go into 13, doesn't go in, or it does go into 12, but doesn't go into 13. Greatest common factor doesn't work. So this has a leading coefficient, so when we're looking at factors on this one, we're really looking at factors of negative 48 that add to negative 13. So now 1 and 48, nope, 2 and 24, those differ by 20. 3 and 16, those differ by 13. So that's the pair I'm looking for. I need to make the 16 negative. So I'm going to bring down my 4x squared. So I'm breaking up that negative 13x to be 16x and 3x. Now that I've created 4 terms, factoring by grouping, first terms have a 4 and an x in common, so I'm left with x minus 4. The last 2 terms, I'm left with a 3, have x minus 4. So I have 4x plus 3 sets of x minus 4s. And again, I can check it. 4x squared minus 16x plus 3x is that negative 13x. 3 times negative 4 is negative 12. All right, number 10. Only 2 terms, not a perfect square, so greatest common factor I'm going to start off with. Well, they only have a 2 in common. So I pull that out, I have x squared minus 16. 2 terms, perfect square, so I need to go another step. So again, the square root of x squared is x and x. The square root of 16 is 4 and 4. 1 is positive, 1 is negative. I got my answer. All right, last 2 problems. Number 11. 3x cubed, whoops, sorry about that. 3x cubed plus 12x squared plus 7x plus 28. 4 terms automatically tells me factoring by grouping. So they have a 3 and an x in common. left with x, or sorry, 3x squared, left with an x plus a 4. 7x plus 28 have a 7 in common, left with x plus 4. So I have 3x squared plus 7 sets of x plus 4s. Again, FOIL it out. 3x cubed plus 12x squared plus 7x plus 28 works out. All right, last one. X cubed minus 7x squared minus 18x. Only 3 terms. So I'm going to start with greatest common factor. They all share just an x. So I have x squared minus 7x minus 18. Then I ask myself, all right, factors of negative 18 that add to negative 7. So I'm looking at 1, 18, 2, 9, 3, 6. Well, the only 2 that differ by 7 is 2 and 9. So I get x minus 9, x plus 2. 9 has to be negative since it's a negative 7. It's negative 9 and 2 make negative 7. All right, whoops, sorry, circle that. All right, that's your review worksheet. Make sure you study hard, practice these problems, even flip to the back side of the worksheet and try to redo these problems again without any help. You have the key in front of you, and study hard, and we'll see you on Thursday for the quiz.